Hi everyone, today we shall discuss the control system lab, that is step response of a second order system. So this is the question like this: C of s divided by R of s equals to 8 divided by s square plus 3s plus 8, denominator and numerator. Okay, this is the denominator and this is the numerator. So you compare with the standard transfer function omega n square divided by s square plus 2 zeta omega ns plus omega n square. So you can observe this equation with this equation. So omega n square equals to what we can write? 8. Okay. So omega n equals to square root of 8. So you will get the 2.82 value. And 2 zeta into omega n value, we know that how much we got? 2.82, that we have substituted equals to 3. Because when you compare this equation, so 2 zeta omega n is nothing but the value is 3. We don't know the value of zeta, but we know the value of omega n. Now zeta equals to 3 divided by 2 into 2.82. You will get 0.53. If it is less than 1, it is a underdamped. If it is equals to 1, it is critically damped. If it is greater than 1, it is a overdamped system. Here they will ask to find out the maximum peak overshoot. What is the formula for peak overshoot? M suffix p equals to e to the power of. Okay, this is not e into. Okay, so e to the power of minus pi zeta divided by square root of 1 minus zeta square and next into 100. Okay. So if you want into percentage. Next, peak time. Peak time is pi divided by omega d. So what is the omega d? Omega n into square root of 1 minus zeta square. So whatever they give the question, first you need to find out the omega n and zeta from the comparing with the standard equation. Then you need to apply these formulas: maximum, peak overshoot, and the next is peak time, and next is rise time. Pi minus theta divided by omega d. Theta is nothing but you can use either cos instead of tan inverse of square root of 1 minus zeta square divided by zeta, you can use cos of zeta, cos inverse of zeta. Okay, because this is 1 and this is square root of 1 minus zeta square and this is zeta. So you can use, instead of tan inverse, you can use cos inverse of zeta and the omega d value. Okay. Next, delay time. No need to calculate, it is a 50% of the final value. Okay. Settling time. Ts equals to omega 4 divided by omega n. This is for 2% criterion. So this is the waveform you will get in the Matlab program. Okay. So when you write this program in the Matlab software, that is numerator. So what we have written is, the question is like this: 8 divided by s square 3s plus 8. So here s square, in s square place there is a 1. So numerator 1, 3, 8. Denominator, only the constant part is there. No s square and no s is there. So 0, 0, 8. Okay. For the numerator. So for numerator 0, 0, 8 and for the denominator 1, 3, 8. And step numerator comma denominator. Grid on. Okay. So if you type these 4 lines, you will get like this waveform. There you should verify the theoretical and practical peak overshoot value. You should verify whether you got the correct or not, and you can verify the settling time and rise time, peak time and the delay time. Right here from 0.10 you can observe from here to and 0.90, that is the rise time. Okay, 10% to 90%, that is the rise time. 50% is nothing but the delay time. Okay, and the peak time you can observe from initial to here, that is the peak time, and settling time, it is settling to the 0 and the steady state here you will get. So this is a from here to here, it is a settling time, and the value from 1 to here, that is peak overshoot. Okay, so that you need to observe in the waveform. So this is a control system experiment step response of a second order system.